Now I'm going to show you how to solve algebraic inequalities. An algebraic inequality is just a numerical statement of inequality to which we introduce a variable. Some example of numerical inequalities are 6 plus 1 greater than 4 and 7 plus 2 less than 1. Now you can see that the first, obviously the first, you can quickly notice that the first is true, but the second is false. Now as we said for equations, when we introduce a variable, the sort of equation changes and it is neither true nor false, and the same principle applies when we're solving inequalities. So a simple example of inequalities is, for example, here we have x plus 4 greater than 8. Now, to solve this simple inequality, we just apply the same rules we did in the previous video when we were solving equation. We just simply subtract 4 from both sides, and we get, obviously, x greater than 4. Another example which I might show you is x plus 1 less than or equal to 0, just to make it simple, because I just want to show you the principle. Obviously, to solve this, we subtract -1 from both sides. I think it's obvious. So we get x less than or equal to -1. And of course, there are various ways to display the solutions of inequality. I'm going to show you two examples, or two ways. So for the first example, we have x greater than 4. Now we can actually display the solution in a form of a solution set, a set builder, which is what we showed. I actually showed how we can actually write a set in this form in the video related to sets. So we can actually write x, the solutions of x, such that x is greater than 4. Another form is the interval notation. So we can actually write it in this form. And the parentheses just means that the interval is actually open. It's not closed. So for example, an example of a closed interval is something like this: a, b between brackets. Brackets indicate that it's closed. And it means that this this a and b are included in the solution set. But here, as you can see, x is greater than 4, which means 4 is not included in the solution set. Now, the other example is x less than or equal to -1. Now, the set builder solution is simply x such that x is less than or equal to -1, and the interval notation is a little bit different because we have, as you can see, it's going to be half open, half closed, and we write here -infinity. Of course, this is just not a number. It is just a symbol to represent infinity, or -infinity in this case. It means we're going from from 0, -1, -2 to infinity, and -1, and we add the brackets to close the symbol, to close the notation, or yeah, from this side. Now, these two intervals we showed here are what we call unbounded intervals, because as you can see, they are not really bounded by anything. On one side we have here in -infinity, and here we go to infinity. So you can see that they're not really bounded between two numbers. An example, the bounded interval is, for example, this is just an imaginary set, so you can think of it just like that. So we have x such that x is between, I don't know, 1 and 2. Now, if we write actually the interval notation for this set, we just get 1 and 2. And you can see that the interval is actually open, and it is an obviously open interval, and it is bounded because, yeah, it is bounded by 1 and 2.